Hello everyone, today I am going to discuss about the gravity or the gravitational force. It is one of the fundamental forces of nature. As I have already discussed in my lecture in normal reaction force, that out of the four fundamental forces of nature, gravity is the only force that exists between larger objects. Now every object in this universe attract each other with a force that is known as the gravitational force. Say for example, we have two objects. Now let the mass of this object be m and mass of this object small m. Then the gravitational force exists between them such that the force is attractive in nature. Now, by Newton's law of gravity, if the distance between the center of these two objects is small r, then the gravitational force is inversely proportional to the square of the distance between these two objects and directly proportional to the mass of each object. Now, if you combine these two equations, then it will become equal to mm divided by r square. To remove the proportionality sign, we can use a constant that is known as the universal gravitational constant. So this is the force that exists between these two objects such that it is attractive in nature. Note in this situation, as the distance between the two objects increases, the gravitational force decreases because the force is inversely proportional to the square of the distance between the two objects, as well as if this object has more mass, or if this object has more mass, then it will have more gravitational force of attraction between the two objects. The value of the universal gravitational constant is equal to 6.67 into 10 power negative 11 meter cube per kg second square. Now let us consider the earth and an object on the surface of the earth. Now let the mass of the earth be equal to this capital M and the mass of the object be equal to small m. The radius of the earth is capital R and the radius of the object is equal to small r. Now the distance between the small object and the earth is equal to r plus r. But since the diameter of the earth is large in comparison to this smaller object, this value can nearly be approximated to capital R. So the gravitational force can be written as m into m divided by r square. This was supposed to be the distance between these two objects, but since this r is very large, so this is the final gravitational force that exists between these two objects. Now if you take this small m and take this value common, this total value common, then gm by r square. Now we know the value of this universal gravitational constant. Also we know the mass of the earth as well as the radius of the earth can be found out. So this value is given by g, that is approximately equal to 9.8 meter second minus 2. So this we know is the acceleration due to gravity that every object experiences on the earth's surface. Thus that the weight of this object is equal to this mass into gravity. Now let us investigate this case. We have an inclined plane at an angle of theta, and on the surface of this inclined plane a block is resting. The mass of this block, let it be m. Now we know that the weight of this block would be acting in this direction, that is mg. Now this is a force that is acting in this direction due to gravity. Now this can be resolved into two components. This is the horizontal component in this case, and this is the vertical component along the inclined plane. Now if you look closely, then you can see that this angle is 90 degree. This is 90 minus theta. This is vertically opposite angle, so this angle would consequently come to be theta. So now we can resolve this into two components, that is, this is mg cos theta and this is mg sin theta. Now in this situation, we know that the plane would be exerting a normal reaction on this block, and in turn the block would be exerting a equal and opposite reaction on the plane. Now let the normal reaction on the block be n. So in this case we can isolate the block and draw the free body diagram of the block. In the free body diagram we only consider the external forces that is acting. Now this is one of the forces that we have found out, mg sin theta. This is another, mg cos theta, and a normal reaction. This need not be taken because it is just the resultant of these two forces. Now you can see that the block is experiencing only the force in this direction because the inclined plane is smooth. We have not considered any friction, so it will try to slide in this direction with an acceleration of g sin theta. So this can be found out by taking, if you consider this direction, then by Newton's law, acceleration will be acting in this direction. So we can write net force equal to mass into acceleration. Only this force is acting, so we can write mg sin theta is equal to mass into acceleration. So this m and m is getting cancelled, so the acceleration is coming out to be g sin theta. So you can see that the block is sliding in this direction with the acceleration of g sin theta, and on this direction we can equate this to, that is n equal to mg cos theta. In this case, if you intend to raise this block through a height of this height from the ground, then you need to, if you see, then the weight of this block would be acting in this direction, so you need to work against this weight. But if you are using an inclined plane to raise the block through this height, then you need to move in this direction, and the weight that you will be experiencing would be mg sin theta, which is less than mg. So that is the reason why people use inclined planes in order to carry loads through a certain height, because it becomes more easier to carry by using an inclined plane rather than by directly raising it through this height.